This is a fully functioning token ring network. Well, except for this machine. But hopefully we'll do something about that in this video. As a refresher, Token Ring was an Ethernet competitor from the mid-1980s, predominantly pushed by IBM. Token Ring uses what's called a logical ring topology, meaning the computers on the network are connected in one continuous ring. A special data packet called a token is passed around, and only one computer on the ring can use the token to transmit data at a given time, avoiding something called collisions. Ethernet, by comparison, used a bus topology. All the machines on the network bus could talk whenever they wanted. This could result in collisions, which slowed down and jammed up the network. Modern Ethernet has solved this problem via some clever tricks and the introduction of networking switches. When you think of Ethernet, you probably think of this RJ45 cable, plug it into a Ethernet network card like this one. This is a Netgear PCI Ethernet network interface, and it's got 10, 100 megabit, and 1 gigabit speeds. It's also got this guy right here. In fact, he's also on the back. I love it when companies put little details like that on their hardware. But for context, Token Ring was a competitor when Ethernet looked a little more like this. This is what's called a thin net card, and you would connect computers onto the network via these large BNC connectors. And these were called thin net because, believe it or not, the prior iteration used thicker cables. I'll be constructing a thin net Ethernet setup in the future, so don't forget to subscribe. All of this is just for context to show you the era in which Token Ring was relevant and the problem it was trying to solve. The heart of this Token Ring network is something called a MAU, or Media Access Unit, with these big IBM Type 1 connectors going into it. You can think of these MAUs as hubs in Ethernet terms. In a previous video, I tried to get a ring network working on this IBM 8228 passive MAU. Passive meaning it doesn't actually require any power, just the Token Ring network cables going into the box. But I came up short with some issues. We'll dive into those problems in this video. In the meantime, this other MAU, produced by Thomas Conrad, has arrived, and as you can see, it's got some successfully connected machines on the ring and plenty of token passing activity going on. So far, I've been able to successfully connect one Windows 95 machine to the ring, this IBM Aptiva. It's got this 3-COM Token Link Velocity XL PCI card inside. I'll show you how I got that set up successfully. I've also been able to connect up this very impressive Cisco 7206 router. It's got a Token Ring port adapter inside. And in fact, the Windows 95 machine and this can ping one another. What you're seeing here is the Windows 95 machine pinging that Cisco router over the Token Ring network. But pinging isn't very interesting. I've got this Pentium machine here, and I'd also like to get it on the Token Ring network. The IBM ISA Token Ring card inside is giving me all sorts of trouble. But we're going to try to solve that today. I've got a bunch more Token Ring cards we can try, ISA, PCI, or otherwise. We'll cover a bunch of Token Ring concepts along the way, do a bunch of troubleshooting together, and hopefully get these two Windows 95 machines fully linked up on the ring. Let's get into it. Let's start by talking about MAUs, or Media Access Units. These are the main pieces of hardware you would typically use to connect multiple computers up to a Token Ring network. Each of these ports in the middle here could correspond to a computer, same deal down here. But on the left side of each MAU, we do have these special ring-in ports. RI at the top here stands for ring-in on this IBM unit. And then on the right, of course, we've got corresponding ring-out ports. In the previous video where I tried to get this 8228 working, you don't necessarily have to watch that video to enjoy this one, but a lot of people made the good observation that maybe you need to connect the ring in and ring out to form a local ring here, but that's not actually the case. So internally to this MAU, it'll connect these up, and these are only used for daisy chaining multiple units together into one very large ring. You connect computers or ring stations up to the Token Ring network with these very large interesting cables. These cables are easily the most fascinating aspect of Token Ring, in my opinion. These connectors have a bunch of different names. IBM Data Connector, I call them IBM Type 1 connectors. They're also called Boy George connectors. And in fact, the IBM Token Ring Networking Handbook from 1993 calls them ugly plugs. And I almost don't want to tell you this because a lot of you would have lived in bliss, but when you plug them in, it's not nearly as satisfying as it looks. You would think this would just be an absolute chonk going in, but it looks cooler than it feels. I'm almost embarrassed to say that. I probably should have kept it to myself. It looks amazing. They're just It's an incredible sight seeing a bunch of these hooked up, so you still, you know, gotta love it. Speaking of having these big cables plugged in, if you think about the logical ring topology that Token Ring gets its name from, the word logical in there is pretty subtle and key. So if you just glance at this thing, this doesn't really look like a ring, does it? At the end of the day, the machines on the ring really do have, you know, an upstream and a downstream neighbor, and a ring is formed. But physically, it's what's called a star topology. So I don't know how to show you this, but this is like the center of the star, and these are the legs or whatever. You'll hear me and other people call it a logical ring topology. That's because at the end of the day, these mouths are actually forming a ring between these. Maybe I'll take a still frame of this and try to draw it on there for you. But physically, the connection might not look like a ring. And these mouths that help form the ring between the ring stations weren't the only devices that you could have used. This looks pretty cool, actually. Can you imagine every single one of these hooked up? By the way, this cable here, literally the physical cable connection between this port and a computer on the other end, is called a lobe. For some reason, IBM calls this a lobe. There was more than just these mouths, and this is IBM we're talking about, so we got to learn some more three-letter acronyms. There were CAUs, or Controlled Access Units. I think this is sort of like an MAU with smarts, they say. I haven't seen anything in the literature that tells me what type of smarts those might be. Maybe like you can actually management over a serial console or something, or it recovers from network errors more gracefully, I'm not sure. Into that CAU, do people call them cows? I don't know. You would attach LAMs, lobe access modules, up to 4 of them, in fact. So I've just got some mouths here, but there were also the CAUs and the lobe access modules. Anyway, more than you ever wanted to know about that. Like I was saying in a previous video, I had tried to connect a few machines up to this IBM 8228. This is like the MAU, in my opinion. It's the one I remember seeing back in the day. I think it's in a lot of pictures and stuff. It's probably what a lot of people think about when they think about a MAU. But I couldn't get it to work. So inside this thing are mechanical relays, and you can actually hear them click as ring stations are trying to get on. But in the end, it would always click another time and reject the station, and we'd get like, you know, error indicators on the back of the token ring NICs. This thing is passive. It doesn't take any power. It only relies on voltage coming in through the connector here, the data connector. And so one common fault, this thing will decide that one of these stations is unhealthy, and it'll kick it off the ring and close this port off. This would have came new with something called a setup aid. It's a little guy you plug in here with like a 9-volt battery on it, and it would reset the ports, reset the relays so that it's ready to accept new stations. So, you know, I built my own, and it, of course, didn't work. Can't believe that. But I have good news. Next week, I am meeting with someone local, and they're actually going to let me borrow their original 8228 setup aid. So hopefully in a future video, we are going to get this working. With all that context out of the way, that finally brings us to this bad boy. This is a Thomas Conrad Corporation 16-port MAU from the late 80s, as far as I can tell. It is a model TC4050. What drew my attention to it in the eBay listing were these buttons on the front. I was thinking maybe those are like automated like setup aid tools so you could reset the port, but it turns out it actually just disables the port. So if you have like a misbehaving station that's ruining your ring, I guess, you can click this and it'll take it off the ring. I actually can't find a ton of information about Thomas Conrad, and I have yet to find this TC4050 instruction manual or documentation or anything like that. Found an article from 1989, presumably when this thing came out, it would have set you back $985 US. That article is also how I learned what these switches are supposed to do. Not a whole ton of information about Thomas Conrad out there in general on the internet. I guess at Comdex in 1990, they announced their very own token bus network protocol called TCNS, or Thomas Conrad Networking Systems. And maybe much more interesting, Compaq acquired them in 1995 as Compaq was trying to gear up their networking division. But I picked this thing up, plugged a couple machines into it, and spoiler alert, it just worked. So we're going to go over that today and get a ring network working. It's really nice that it has these indicators. These top ones go green if it thinks the ring station is healthy, and you even have activity lights on the bottom here. And if we flip it around, as opposed to the 8228, it's able to accomplish all that because it's powered. Now, I don't know that it's what you would call smart. I think the article even still called it a dumb MAU with 16 ports. So it's not very sophisticated, but the lights on the front are a huge win. And those relay clicks I was showing you from this guy, I am happy to report this big guy does those as well. So I'll try to catch some of those on audio for you. We probably ought to crack this guy open, you know, for posterity. See what's going on in there. It's got a tiny bit of rust on the screws, a little bit on the cover here, but nothing that scares me. And like I was saying, I already know it works. 14 screws later, at least they're all the same size. We should be able to pop this lid. Oh yeah, it's loose right off. Oh wow, very cool. That is awesome. You can see the mechanical relays down in there. Got a transformer to turn the mains into logic level that this thing needs. Look at these tiny little wires for all the data connector ports. Ribbon cables probably for all the LEDs and stuff. Wow, really, really cool. The corner of the board there, we can see copyright 1989, Thomas Conrad Corporation, made in the USA. Yeah, that was worth the 14 screws. Very cool. I'm going to button this back up. Let's finally actually do some token ringing, shall we? This IBM Aptiva is running Windows 95. I've got this 3COM Token Link Velocity XL PCI card installed in it. Luckily, it came complete in box. The card is in excellent shape, and it came with all the drivers. So I got that successfully installed, but I couldn't really ever tell if it was doing anything right with the old IBM MAU. Starting to think maybe there's something wrong with that other MAU. But I can get it to work successfully with this one. This PCI card comes with a DOS configuration utility, which actually lets you set the speed of the card and administer it. Speaking of those speeds, here's an IBM ISA token ring card, and you can see it says Auto 16.4. And on the edge of a lot of these cards, you'll see they say 16.4 as well. That stands for either 4 or 16 megabits per second. Those were the two initial speeds for token ring. And any given ring can only operate at one speed. So that's why it says auto. This thing should theoretically go off and try to figure out what speed it should operate at. And I believe, at least in the case of this IBM MAU, 4 megabits is all it supports. And my hunch is that 4 megabits is all this supports. So I'm going to fire up the DOS program for this thing on Windows 95, and we'll configure it to run at 4 megabits. I'll show you how I did that. I think that was a critical step in getting this working. And I'll also show you a bunch of the different behavior profiles of like when this thing's booting up, the clicks and clacks this thing makes, how it behaves when it's on this one. And in fact, when this thing is like trying to get on the ring, the whole operating system freezes while it's like attempting to connect to the MAU. If you talk to folks that actually lived with Token Ring and were administering those networks, kind of the consensus is it was a nightmare. Lots of odd failures, lots of weird behavior. At the time, a technically superior technology to Ethernet of its day in, say, 1985, but just tons of headaches is my understanding. And I think we're going to see what those folks are talking about throughout the course of this video. I'll show you some of the odd quirks and behaviors these things have. Got everything hooked up here. We've got Windows 95 running. And I'm going to show you the absolutely bizarre behavior this token ring card unleashes on this machine when it can't insert itself into the ring. Yeah, you pointed at the card here. Let's get into Windows. It's already happening. So the mouse has totally frozen up, and I can't interact with the machine. See there, a little bit of activity took place, and the cancel button is clicked now. I'm not actually pressing the mouse anymore. In the previous video, I'd been complaining about this machine just locking up like this, and I couldn't move the mouse, so it always came back, and I kind of chalked it up to either driver issues, and a bunch of comments came in that said, oh, maybe the Pentium is overclocked or something, and it's leading to this instability, which I thought was a good guess. But it turns out, this is what happens when this card is trying to insert itself into the ring. It locks the entire machine up, performs checks, even though there's no cable, and eventually, the machine will come back to life. So yeah, here we go. We got into Windows, and that's just going to keep happening periodically. The whole thing will freeze up, won't have any mouse control, and then it comes back. Let me show you how I figured this out. I learned about this by experimenting, getting this thing all cabled up. And remember, I can hear this MAU click when this thing tries to insert in the ring, and we can use these indicators here. So let's hook this up. I'll show you the behavior I see with this MAU. In fact, it happened right away. So the mouse is totally frozen, can't move it. We see a green light, and I heard a click on the MAU. It's performing some checks, and it's eventually going to give up. It clicked, lights off, and now I have mouse control again. It's super bizarre. So when the ring network is misbehaving and I can't connect, this machine's basically unusable because at every few moments it like freezes up. I don't know that that's like a dig on Token Ring in general. That seems more like this card being funny with its supposed Windows 95 support, but yeah, it was driving me nuts trying to figure out what was going on, and I finally did. Let's power up this other MAU. Get this one plugged in. There's no power switch. You just kind of get it powered up. All the lights turn on like that. It's ready to go. While I was grabbing that cable and plugging it in, every once in a while, this thing tries to get on the ring again, freezes up the OS, clicks and clacks, gives up. Super weird. In fact, it's doing it right now. However, if we connect to one of these MAU ports, we see an activity indicator right away. See if I can capture all of this. There's no indicators here, so it's not actually trying yet. I don't really know what's happening, what kind of network activity is taking place, but this card isn't trying to insert yet, I don't think. I heard it click. We have a green, and the OS is hung up right now as it's trying to perform its load check and make sure that the MAU is healthy. And the OS is back. We are on the ring network. We have one ring station, but we're legitimately on a token ring network. Everything's healthy now. And from now on, this machine won't lock up anymore. It's on the ring, the card's not trying to get in and out all the time, and everything just works perfectly. It's so strange. Let me show you some interesting DOS configuration utilities that came with this thing, which were pretty critical. I've got the contents of the CD that came with that card on the desktop here, and there's this little 3 PCID. And as I recall, it's actually going to kick the card off the ring. So let's watch those indicators. Yeah, immediately booted the card off the ring. And my capture setup did not like that. It's going off and finding information about the card, and I think the machine's hung up again. It's actually really hard to use this because it keeps freezing every once in a while because we're off the ring again. And we're frozen. It's just stuck here for the past few minutes. Keyboard does nothing. Can I control delete? Control delete does nothing. So I'm going to restart the machine. It's rebooting now. I'm just going to leave it off the ring. And in between attempts to insert when the machine's working, I'm going to try to fire up that program to show you really quick. This is how I had to do it last time. What a classic. It just froze up, so I'm going to wait for it to clear to give us the max amount of time for this stupid program to load, and hopefully we can look at it. All right, go. Well, maybe it just doesn't work anymore. Yeah, it's just frozen like this again. What? Well, I guess you're just going to have to trust me that I used to be able to run this DOS setup utility, and you can run tests against the card. They always failed even when it got on the ring successfully. I was able to change the speed between 4 and 16 megabits in one of these menus, so you'll just have to imagine what this was like to use. So, just so much fun. Well, you saw, this one can get on the token ring. I wonder, maybe I should plug it back in. Wonder if that'll, bring it back to life. Maybe it's trying. That did nothing. This is what these buttons do, by the way. They completely deactivate the port. Kind of cool. Well, the Aptiva is going to work as good as it's ever going to. It can connect to the ring network. Let me show you the behavior of this one that's been giving me trouble. I've got it connected up right here. It always exhibited the same behavior as the other machine on this MAU. A click, try to enter, a clack, rejected off the ring by the MAU, I think. So, need to reset those ports, or maybe something's physically wrong with it. We'll show you what it does on this one. Windows 95 hasn't even started booting yet. This is the behavior of the card while it's booting up. We can see a green, heard a click on the MAU, and it is theoretically successfully connected. But I think I have a driver issue, or maybe further hardware problems. No, never mind. Ooh, there we go. Rejected off the ring. And after said rejection, it just blinks amber like that. The problem with this one feels driver related. Windows 95 recognizes it, no problem. A key to getting it to do anything correctly is putting it in this real mode NDIS 16-bit driver mode. By default, it wants to work in enhanced mode, and that just doesn't work. The card does essentially nothing unless it's in this real mode setting. I do have it bound to TCP/IP. Removing all or none of these does nothing, doesn't change the behavior. The problem is if we go to Device Manager, it thinks something's wrong. So it's complaining about resource conflicts. And unfortunately, if we go to set the resources manually, you can scroll through all these. It's not the IRQ. It doesn't think there's any conflicts. So driver, or I just don't know how to get this thing configured properly. And that might have been confusing as we were watching it come on the ring. So it attempts to get on the ring and eventually gives up and bails when it's the only ring station. What I'm going to do now is I'm going to hook the other machine up, power it up, and with that guy successfully connected to the ring, the second machine will connect, But again, I can't interact with it in Windows. Something's wrong. I can't, ping or use a TCP/IP stack or anything like that. Got the Aptiva fired up. It is on the ring. That's this connector right here. This other machine we're experimenting with that's broken is this one. I'm going to restart it because it's just sitting here in an error state. Another oddity of token ring stuff I've found, especially with these older ISA cards, is you have to totally reboot the machine to get it to reinsert into the ring. I mean, I guess I prefer that over the machine just locking up every 7 seconds. So, beggars can't be choosers. Windows splash screen is up. It's trying to stay inserted. Let's see if it stays. The last time I experimented, it did. I think it's going to. So it stays on the ring, right? Light's green. The card thinks everything's fine, so does the mouse. But over in Windows, I'm not getting the kind of network-style logon screen, which is always a bad sign. And I can't do anything. I can't interact. I tried NetBUI to see if I can see that other machine. We can't ping. I think I showed this at the beginning of the video. But WinIPconfig just can't even start, which means there's like a IP stack error. So yeah, I'm stuck here with this card that's almost working, but a resource conflict complaint. I suspect I just don't know what I'm doing. Let's get this thing powered off. It's really fun hearing these click and clack as things enter and leave the ring and watching the indicators. I don't know, having fun with it. This is the type of card that's in that machine, and I have several of these that I've tried, and I think most of them are functional. I just can't get them to work on Windows 95, but it's our lucky day. Look who just showed up in the mail. Some PCI token ring cards. Also IBM branded. It's a 16.4 token ring PCI management adapter card is what it's called. It's got the RJ45 and the D-sub connector here. 16.4. Wake on LAN. That could be fun to try someday. Do a Wake on LAN on my home lab token ring network. I'm going to pull the ISA card and get this guy in here, and then I suspect we're going to have yet another driver battle. I highly doubt Windows 95 is going to know what to do with this thing right out of the box. I have a lead on some drivers. I don't know. Let's try it. I'm just going to plug everything right in and let her rip. That's good. It's not totally dead. I didn't catch it, but it was able to spit out its own message at post about token ring initializing. Aha! I forgot to remove the old card in Windows before physically removing it. We'll see how this goes. I might really regret that. It found it, but again, it's going to want, drivers. Yeah, so it doesn't know what to do with this thing. That is not too surprising. Scouring the internet all over the place for these drivers, and I found this CNET download page for 7511402.exe, and CNET thinks they scraped the README and that it supports this IBM 16.4 token ring PCI management adapter, which is the cards I have. I got 3 of them on eBay. Downloaded that and was looking around. It's of course just a self-extracting zip thing, exe. And take a look at the README, and it says IBM PCI token ring network driver for 95 through 2000. Must have shipped from Gateway. This might have been something they provided with their machines that had token ring adapters or something. And it's got the Windows 95 instructions. I'm not too optimistic yet, but we're going to try it. There is a nice optimistic note about Windows 98 ships with the device driver, at least for the token ring PCI adapters that this thing concerns itself with. So that might be another avenue for us. Try out Windows 98 if this doesn't work. But I have a problem. This pile of drivers is almost 8 megabytes, so I can't just throw it on a floppy. And that's one of the only ways I have to get stuff onto that Windows 95 machine. So I think I'm going to be burning a disk, 8 megabyte CDR. I'm not proud of myself, but here we are. Getting it unzipped right now onto the C drive. If this doesn't work, this video's cooked. Might lose the shop. Let's update the driver. I can never remember how to do this. There's like some way to point it at a driver. Have disk. Here we go. It's sitting in here. Oh ho ho. That is our device. Oh, let's go. Come on, Windows. Okay, that's fine. This is really common. I've got the Windows 95 install media sitting on my This keyboard's weird. Sitting on my hard drive. Oh, system failure. Try changing the driver for this device. Okay. Oh, don't go to the resources tab. Whoa. Oh no. I think we're gonna restart. I'm honestly shocked that it didn't prompt me to do that in the first place. Oh, it's trying. It's trying. It's staying. We're at the Windows splash screen still. Indicator on the back of the card is staying green. Oh, failure. Dang it. No. Your adapter is not working properly. You may need to set it up again. Oh, it thinks it's trying though. It's trying again. It just clicked, will it stay? A few moments later it's no. I feel like we're just so close. We do have the networking login prompt now. Remember I was showing you we didn't have that before. Okay, it can't get in the ring. It just flips back and forth like I was showing you, but Windows does think everything is fine now. So if I go over to Network Neighborhood, which we have now, and let's go take a look at this thing. It's got all sorts of options. I wonder if I can force it into 4 megabit. There we go. Let's force it to 4 megabit. And we might have to restart for that. Yeah. Let's see what that does. That was it. It's staying on the ring now when I hard code it to go to 4 megabit. I wonder if that's what was wrong with the ISA cards. I could never figure out how to... I mean, I tried in its little settings that Windows showed me, but I could never get it to go to 4 megabit, I think. That is exciting. Yeah, stay in green, stay in green. It's in the ring. Oh, we're so close to both of these being on. I can taste it. So let's power up the Aptiva and see if it'll get in the ring happily. All right, here's the setup on this one. We've got NetBUI, which will allow files to be shared between the two computers. The token ring adapter is set up to have that as its binding. All good there. Also, check this out. This thing is like way more advanced. We've got this route switching stuff. Pretty nice card. I'm glad I bought 3 of them. Of course, I added file and print sharing. That's a pretty critical piece. And you click this little guy right here to give access to files, and then you can start seeing other shares. And check this out. Open Network Neighborhood. There's the Aptiva. This machine we're on now is called KST. Go into the Aptiva. It is sharing a folder. And I think the way you set something like that up is you go to the folder properties, and your network's operating properly if this sharing tab shows up. You have all your settings right. This just literally won't show up if not, but we'll call this KST share. Let's make this full access. Oh, it wants me to give it a password. You don't get to type that twice. Never mind, I lied. So you can see the little icon changes to the little share hand on the folder. Let's go to the other machine. Over on the Aptiva, if we go to Network Neighborhood, and we can see that share I just started sharing. Oh, and it wants my password. Security was a little different back in the day. Oh my God. I am typing the right password. It's not working. Pro tip, I just removed the password on the other machine. And we're here, and I think I should be able to create stuff now. Yeah, this is a full access share. Hi, we'll save that. Really stunning display of token ring networking power here. I think this will come as no surprise. There it is on the other machine. This is amazing. This is a token ring network working perfectly. I almost never thought I'd get here. This is so cool. I'd like to do something else. I have the TCP IP stack added on that Aptiva. So I think we go into Microsoft TCP IP. We'll probably need a Windows disk. Or, this will happen. Nope, just a restart. Oh, this is good. I do want to see those messages. That's a good sign. There are 1 users connected to your computer. I'm on the share on the Aptiva. That is so awesome. I love it. Here's that token ring ROM initializing post message I was talking about. That's that PCI card. I do never get tired of looking at this. Always satisfying. Okay, so this means the TCP IP stack is working. It's trying to talk to a router and get an IP. Of course, so let's get in here. Let's see if we can run winipconfig, and we can. It knows about the token ring adapter. I'll show you how to assign an address. You go over to TCP/IP, and it's right here in the properties, so it's actually trying to get it from a DHCP router, obviously. I have that other machine kind of on a funny subnet here. Let's add this one here. It probably is going to make us restart again. Yeah. Woohoo! The computer name you specified is already in use on the network. What? We're just not going to worry about that. I need to get video drivers on this thing. Look how small that is. At any rate, we're going to try to ping the Aptiva. And we are getting replies. Let's ping the machine we were just on. We're in. I love it. Got file share working. We've got TCP/IP working on both machines. And that is important because in a future video, we're going to leverage some Cisco gear. This is a 7206. Got a couple token ring ports in it. And I'm going to use this as a bridge between the token ring network and another Ethernet network. And hopefully we can get these Windows 95 machines pinging out to the internet via their token ring network, bridging over this. I think you get the idea. That's going to be fun. Just for the hell of it, let's fire this up and get it on the ring. We'll have 3 things on the ring. I'll use this RJ45 token ring card right here. Plug him in here, just like that. This is the serial console of that big router I was just showing you. It's sitting right next to me on the desk. And I think its little battery inside is dead. It can't store its configuration anymore, but that's no big deal for what we're doing right now. And we'll get in here, and that interface I just plugged into was 60. Let I put my cable in. I think we need to give it a ring speed 4. That seems to be important for these older MAUs. We'll give it an IP address, and then we'll tell it to come up right now. It should try to insert into the ring. We can see the green light. I'm watching all the indicators over there. And I think we're up, which means, can we ping the KST machine, the machine we've been working on? We can. Let's try to ping the Aptiva. I think he was on 5. And we can. There we go. This is easily the coolest network I have ever built. It's going to be hard to top this one. It is so satisfying to have both of these Windows 95 machines on this ring working perfectly, being able to share files, totally networked. Super jazzed about this. But what comes next? I can think of at least 3 projects. I've got an IBM PS2 model 55SX. I don't have a way to get a hard drive in this thing, but I believe we can get it on the token ring network and net boot it on the token ring network. Yeah, I think that'd be pretty sweet. Give you a little taste of this big 7206 over here. Bridging between the ring and a Ethernet network is definitely on the list. I really want to accomplish that. I think that'd be really interesting. And then I've got a massive IBM RS6000. I need to actually get AIX, IBM's Unix variant that would have been running on it back in the day, on there. I've got plenty of token ring hardware to put in it, so we will definitely attempt to get that on the token ring. A bunch of miscellaneous stuff to tackle as well. Try to get this 8228 working once I borrow a setup aid. I've got a handful of PC MCIA token ring cards, so I need to get some laptops fully functional. That'll probably be part of the video. And get these installed in there and get them ringed up. And then I suppose it wouldn't be the end of the world to maybe rack all this up in what I'm calling the retro rack in the other room, where I kind of have retro networking gear and servers. It'd be nice to have like sort of a permanent setup for this and a token ring network I can play with in a more permanent fashion. But today we're going to celebrate the small things. We have a fully functional ring with 2 Windows 95 machines. I know a lot more about how to get this stuff set up. This Thomas Conrad MAU has been a lifesaver with its indicators and, well, just the fact that it works. I hope you enjoyed following along as we troubleshooted and succeeded in setting up the ring network. I've got plenty more videos on the way, so if you haven't already, please consider subscribing. I am almost at 50,000 subscribers. And of course, most of this would not be possible without my patrons. If you really want to support the channel and see behind the scenes type footage, early release videos, definitely go check that out. Hopefully you had fun. Thanks so much for watching. I'll see you in the next video.